short summary of what we need to know about a graph trapezoid. The graph trapezoid, you have an axis here, represents some quantity, and implicitly there's a vertical axis that represents some other quantity. The graph trapezoid has graph altitudes here and here, altitudes relative to the x-axis. Now those are not actually altitudes of a trapezoid. The altitude geometrically of a trapezoid, the geometric definition, is the distance between the parallel sides. That's not what we're talking about here. These look like altitudes. When they appear on a graph, we call them graph altitudes. And the trapezoid has a width. Okay? Trapezoid has other quantities associated with it, like a run, a rise, and a slope. Now, the picture's going to get a little messy, so let's use a different color for the average graph altitude. That comes to the midpoint because the trapezoid has a straight line up on the top. If I was to cut this little triangle here off, flip it around, and put it here, I would have a rectangle. The rectangle has then a height and a width, and it has the graph area. And that area is the average altitude times the width. These things all represent quantities, or they don't always represent quantities. The area doesn't always represent a meaningful quantity. Usually the slope, the rise, the run, and everything else do represent reasonable quantities. And when the area does represent a useful, not reasonable, a useful quantity, then it's often very, very useful. And in here you see the seeds of the entire calculus and the fundamental theorem of calculus, whether you know it or not. This is something we really need to know, and this is critical to interpreting graphs.